Okay, welcome back. I got tripped up at the end of the last video because the batteries on my mouse ran out. And so that's why if you look at the end of that video, you can just hear it scrolling around and me saying nothing, trapped, like I caught like a deer trapped in headlights. Anyways, so now that we've talked about the degree, well, for the last thing I'll say about the degree is very easy to find when you're looking at a polynomial that's in standard form like this. Remember I said that there's another form that they could be written in, which is factored form. And in factored form, you kind of have to count the number of x's to figure out what the degree is. So here's an example of a function that's in factored form. And I see there's 1, 2, 3 x's, so it's going to be x cubed. Other times you might have one like the one coming up right here where I have to count the x's, but one of the x's is squared. Okay, so this polynomial right here has a degree of 4 because there's 1, 2, 3, 4 x's. Okay, and remember what we said about the link between the degree of the polynomial and the number of humps. That's going to be true throughout. Now, the other thing to pay attention to is which way the arms are going. Okay, the arms, in this case, there's a right arm and a left arm. And what you can think of the arms is the way the function is going as x goes to infinity, positive infinity, which is out to the right, or negative infinity, which is out to the left. Okay, and that all depends on the leading coefficient. So the leading coefficient is either going to be negative or it's going to be positive. Now, if you look, this is negative, this is positive, this is negative, this is negative, this is negative, this is positive, okay? And so what the leading coefficient, whether it's positive or negative, tells you is which way the right arm points. So in the case that the leading coefficient is negative, the right arm points down. In the case that the leading coefficient is positive, the right arm points up. And then what you can look for is whether the degree of the polynomial function is odd or even. If the degree is odd, like in 3, the arms point in opposite directions. If the degree is even, like in 2 and 4, they point in the same direction. So odd, different directions, even, same directions. And you can look at the different functions and you can tell a lot about the way they point based on the leading coefficient and the degree. Okay, and it takes some time to pick this up. I'm rushing you through it, but that's how we are able to do this year. The other features of the graph that you're going to be looking at, paying attention to, are the intercepts, okay? And so remember what the intercepts of a function are. Well, there's a y-intercept. The y-intercept is where the graph crosses the y-axis. At the y-axis is where x is equal to 0. So to find the y-intercept, we're going to let x equal 0. This is the lesser of the two important intercepts in polynomial functions, I think. But this screen right here is showing you how to find the y-intercept by substituting 0 in for x. And they actually do a pretty good job here of showing you how to do it. But I think you could look at this for a while if you don't know what they're doing and not really understand. They're plugging 0 in for x to get the y-intercept. When you do 0 for x, these calculations inside the parentheses are pretty straightforward, and you get 1/4 times 40, which is 10. The other concept is the x-intercepts. And the x-intercepts in a polynomial are often called factors, and they're often called roots. And they're the values of x that make y equal to 0. So they're numbers that I can substitute in for x and make the whole function equal to 0. And remember, I think sometimes you fall into the trap of thinking x can take on different values within a function. X can only take on one value, where x represents a variable that can take on many values, but within a particular point, x is only one value. So if I plug in a number for x here, like let's say -2, I'm going to get 0 in the first factor. I have to put -2 in for x because that's what it equals. -2 plus 3 is, or -2 plus 5 is 3. So I have 0 times 3 times 18. 0 times anything is 0. So when I let x equal -2, I'm going to have a x-intercept or a root or a factor. And the same thing when I let it equal -5, and the same thing when I let it equal to -20. And A lot of the graphing of functions involves figuring out what the x-intercepts are and sketching an appropriate graph. Now, just one last thing is that the x-intercepts or the roots are going to look different when you have a factor that is squared versus when you have a factor that's not. Okay, and this activity, I think, helps you understand the difference. So I don't want to exactly give that to you yet, but they are going to look different if it's squared than if it's just one of those factors. And let's see, an example where you have one that's squared. Like here's an example on slide number 15. That -4 is going to look different than the 3 and the 1. All 3 of those points are going to be x-intercepts, but the -4 is going to look different than the 3 and the 1. And so hopefully you can investigate a little bit and determine what the difference is when the factor is squared today.